So this is the third installment in the series of machine design. Watch me figure it out here at the West Michigan Lakeshore SolidWorks Users Group. And close some of that. We'll do this. I started out with a design courtesy of some of my friends at JSK Specialties. Nope, wrong one. Let's try I can type. And I uploaded one of the videos, one didn't record, and the files. So if I can find it again, I'll download.
Well, I'll come back to this.
Yeah, no one wants to hear that. And I'll download the files that I started out with last time, or ended with last time. And we'll continue that as we go. Wait for those to download. So one of the user group leaders always have a survey, and you can put down what you like and disliked about the classes you attended. And one thing that people disliked was I didn't prepare a presentation and I just kind of figured it out, which was kind of the point of the presentation, but some people didn't like that. So I kind of thought about it today. Yeah, I just got back from a 10-day trip in California. My brain's still a little fried. But I thought about it a little bit, and then I did download the files a little bit earlier and tried a couple things. So maybe the first 15, 20 minutes of this presentation will be quasi-rehearsed. And then after that, who knows? And then my friend last time that gave me the files and told me what it had to do isn't here tonight, so I'm just going to make it up. Because then it can't be wrong, right? So sorry that the internet is taking so long. While we wait, any questions? Who was here for the first two presentations, the first session? I know Robert was. Anybody else? Wow, a couple guys in the back. There's chairs up here. Y'all can come up front. I don't bite often or hard. Really don't know why that's taking so long to download. Well, thanks for coming back, those who were here first, and thanks for coming for the first time. Oh, come on.
What were you doing in California?
I was doing some sales, and there's a friend. So I did an install at a customer in San Francisco, so I spent a week there, and then drove down Highway 1 to Santa Cruz, hung out with a friend that I hadn't seen in a decade, and then drove down to Paso Robles, or Paso Robles, however you pronounce that, and then down to Los Angeles after that. So I typically put more miles on my rental cars than I do on my actual cars, so for what it's worth. It's the first time I ever rented a car that actually had a problem with it. It was higher mileage than usual. Usually my rental cars are like 25,000 miles or less. This one had like 40-something thousand miles on it, which mine have 200, so whatever. But actually a check engine light came on and transmission problems, so I got a new car halfway through. Always exciting. All right, so I got the CAD data downloaded, and we'll start now with the actual design side. What I had thought about was why I was getting these errors in the tree. Anybody download the data or play with it or think about it, why I might have had these errors? I figured out what my mistake was. I meant to put this part in an assembly and orient it, and then make that a subassembly that put in everything else. So let's do that now. And I'm using 2018 this time just because I found it a little bit more stable. Last time was 2017, so I'm going to save all now just to upgrade the files so we don't have that performance hit if we crash or something happens. And then after I save everything, I'm going to just make a copy of my machine files in case something goes horribly wrong and I can't recover. If you had PDM, this wouldn't be a problem. PDM is great, right, Todd? How awesome is PDM? It is very nice. You heard it from Todd himself. Well, not if I make changes, and I just upgraded the files. But yeah, you could. So I'm going to right-click on the component that I want in an assembly and say, for some reason I can't read today, new assembly, and then rename that assembly. So pro tip, keyboard shortcut, this is any Microsoft Windows rename function. So if you select anything in the Microsoft Windows universe and hit the F2 key, like right next to the F1 key, which is help, the F2 key will do a rename. So that works in SolidWorks as well. It renames anything in your feature tree, and in this instance I created a virtual assembly of that component, which is now assembly1 caret inside the component. So I want to rename that to customer, if I can spell or type, customer CAD assembly. And now that it's renamed, I can right click on that and hit the save assembly and external file, save assembly only. So this isn't a virtual components presentation, but this is what this interface is. This interface is kind of terrible. I don't like it because it's clunky and hard to deal with. Usually what I'll do is just open the virtual assembly itself and then run a file save as and dump that into the desktop or wherever it is I want to save stuff. You can save it either way, right click, save into external file, or open up the assembly and do a save as. Now, what I should have done is use that mating, and in the first assembly, I'm not going to take the time to do it right now, so I'm going to fix this. I never fix anything. So just the fact that I fixed it there means that I'm lazy and trying to optimize the presentation. So to get rid of these errors, what the problem is I think it's these angle mates, I'm going to guess. I didn't get this far earlier today. I delete those angle mates. Then the origin of my assembly should match the origin of my other assembly, so I can mate the origins together, and my errors went away. So that's what I intended to do last time. I just kind of forgot that one step and then got myself in trouble. Back to the design at hand. Now I got to kind of look at this, remember what I was doing last time. Okay, so this particular component, yeah, we'll talk about that. So, and I was asking my friend up here what the constraints were, if they allowed exposed bolt heads. And I don't really remember what he said. But let's pretend that we don't want an exposed bolt head. So I think these two outsides are dowels. So it's a 1/4 inch clearance dowel through the main block. And I think we talked about that a little bit. We clearance blocks that are blind so that we can slip them in and out. And then we do a press fit on our plates so you can pound them in and out. And that's kind of the rule here. In this instance, you only need 2 dowels and one bolt to hold it in place because the dowels are alignment, bolt is just clamping force. So let's say that these dowel holes in the plate here could be blind. Maybe they should be blind. We'll say should instead. Because we can, out through is fine. And then let's say this should be countersunk is kind of what I meant to say instead. So let's do a socket head cap screw. Countersink, it looks like it's from the other side, which is fine. That part will update. So we'll declare this part as the primary hand, and then we want to mirror this part to get it to work, right? Because they're handed parts in this instance. If the request is not to always have the whole countersunk, allowing the bolt to be on the outside of the plate would save you another part number, save you a mirror, save you a detail, and save you another setup. If it's company's spec or there's other compelling reason, mirror. This is one of the instances where, depending on the customer, what is, I might recommend, either use a button head if it looks nicer, or don't mirror it and just leave it a through hole because it would save you a part number. But for the exercises of this presentation, we'll just mirror it and be done with it. So this is the way I like to mirror things, and there's a reason for it, and I'll explain that. So let's pick a plane, do a mirror, grab the body, uncheck knit bodies, delete the old body, put this mirror and this body delete in a folder called mirror, and then create a sub-component or sub-configuration called mirrored. Now in reality, we should be using part number, so this is riser 03. So again, who knows that you can rename SolidWorks files inside of SolidWorks? If you click on component 3, you can do it in the feature tree or in the configuration manager. If you click on component 3 and hit F2, you can actually rename component 3. I'm going to do -X. And it'll allow me to update references. So now on the desktop, I have 3-X. Right, just to prove this, here's in my Windows Explorer, 03-X. I'm going to change this to Andrew. And so in SolidWorks, it's 03-X Andrew. In Windows Explorer, it's still just 03-X. When I hit the save button, it'll ask me, do I want to update the name on my hard drive? And this works the same with PDM. It's now 03-X Andrew. So you can actually do full file renames inside of SolidWorks without having to do a file save as or open up Windows Explorer and rename it and then remap references. PDM makes all that a lot easier anyway, but it is possible to do it here inside of SolidWorks natively. And again, I'm just using the F2 key so I don't have to wait for the slow double click. So I'm going to call my original hand 0 because in my computer programming world, you start counting at 0. and then change these configuration properties to use the configuration specific name and not the document name. We'll get into that later when we look at the bills of material. So now riser 3, I want to suppress that mirror folder. So there's my original. And then for riser 3.1, which is the mirrored hand, I want to unsuppress that mirror folder. So there's my mirrored hand. So I've got a full mirror inside of a single part using configurations with no external references and no reliance on the assembly. Now this particular part, I'm just going to change to the other configuration. I'm sure a couple mates will blow up, no big deal. We'll delete them all. And then use the right click select other to remate it in place. In this instance, I may choose to mate the dowel holes here because I'm assuming this block is holding everything down, yep. So there, now I've got mirrored parts, one SolidWorks part file, two configurations, two different SolidWorks names in the bill of material. And I'll show that in a minute. Let's just quick make a bill of material while we're thinking about drawings. Anybody have any questions, or did everybody follow that? It's all recorded. You could probably step through it yourself. I'm not probably going to spend too much time explaining it, but I can take a quick question if somebody has one. Yes, you can.
No, you can't.
Oh, yes, you can. I'll prove it to you. I'm loading the Counterpart add-in, the other software company that Jeremy mentioned, because, oh, we gotta save this. Is Rick over here, great customer of mine, thinks that it can't be done. So here in the SolidWorks bill of material, we have proper riser 030, 031, and as I click on these components, once we rebuild and we get our image back, when I click on these components, you can see that it's highlighting that first component, and this is highlighting that second component. If you look at our Counterpart add-in, which I wasn't planning on doing today, but Rick told me to, we can see here that we have in the proper bill of material, riser 030 and riser 031. The key there for SolidWorks or for Counterpart just integrates with SolidWorks and does whatever SolidWorks says. So this isn't a Counterpart specific or anything. The key is that in this part file, in the configuration manager, bill of material properties, we choose configuration name. So this configuration reports to SolidWorks, which is what Counterpart uses, that its name is 030, and this sub-configuration name is 031. So that's a SolidWorks universal rule. Counterpart just uses it. It's not a Counterpart demo today, folks. The other thing that I will bring up in Counterpart is an easy way to demonstrate it, but we'll look at our drawing here in a minute, is if I do an indented bill of material. So let's do indented detail numbering. We'll notice here we have our subassembly and then our parts. Well, we don't really want that. We want this all excluded from bill of material anyway, but it brings up a good instance where there's another configuration option, is that for children you can hide. So if you hide the children, you can turn a subassembly into a part. Counterpart recognizes that here. Here's the customer CAD assembly. Excuse me, we can see that it's just a part icon. And if we go back to the drawing, we'll see that that indented goes away. So now that the top level, parts only, and indented all basically look the same, because it's a single level assembly. It doesn't recognize that subassembly is existing. It recognizes that subassembly as a part. The really practical application for this is like a downloaded pneumatic cylinder or a cabinet door that's opened where you need the subassembly for the kinematic motion, the cylinder to expand or something, but you want it to show up in your bill of material, your SolidWorks bill of material, your PDM bill of material, or Counterpart bill of material, whatever it is, right? Bill of material is bill of material. You want it to show up in your bill of material as a part, and that's the option. It's only available on assemblies, so if you're in a part file, you can't hide the children of a part because parts don't have children.
Does that work for data cards and PDM?
It does. Well, it depends on how it's set up. You'll have to talk to your admin. I was going to make a joke, but this is being recorded, so. The really good thing the other thing I would mention, Todd, is if it's like a downloaded pneumatic cylinder and you want it to be a part, right, but you still need the kinematic motion, for the subcomponents, what I would do is I would make them virtual. So, okay, So then that way, PDM doesn't recognize them as a file.
Always have data cards on everything.
Yep, it does. All right, so I just excluded that fixture assembly from my bill of material because I really don't want that in my BOM, right? I'm not gonna make that, I'm not gonna buy that. Going back to SolidWorks here, the drawing, we'll see that that fixture disappeared. I just got my base plate left, I'll have to rename it at some point. And then of course, SmoothLogic's also updated accordingly. So we'll get rid of SmoothLogic's for the rest of the presentation unless Rick has another question. Okay, not to pick on Rick, but he started it. So that's how I would do mirror. I don't like the external references if I can avoid it. Obviously this entire design is external referenced up the wazoo, but from a mirror standpoint, that's just an unnecessary risk. That's just unnecessary. So we've got a lot of fixtures here. I think Jerry was here last time and he said that we needed a Destaco clamp or something to do that. So I think I'll download my first downloaded file. And let's see how that goes. Now I haven't, in all fairness, not downloaded Destaco clamp in a long time, so if anybody wants to tell me a good part number or a size, thank you. I appreciate that. 210U. Whoops, looks like my num lock was not on. Oh, it was. I will trust you for the sizing, because I haven't done this in a while. So it looks like SolidWorks will give us a part, which would not be helpful. FeatureWorks, yeah, I don't want that. Just try a zip, I hope, I think. What do you want me to do? Parasolid. I do like parasolids. It's very convenient that they either don't make you log in or I auto-logged in somewhere. It annoys me when you have to log in. I was hoping I didn't have to create an account or something. Looks like it just let you download. That's super great. It's almost as good as McMaster-Carr. So while we're waiting for that, let's go to McMaster-Carr and say I need to get some rubber bumpers. What do you call those? Sorry?
Clamp spindle.
Spindle? Did I spell that right? Wow, Radar is on it. I don't know why I'm presenting. You should do this, Radar. With rubber fixed flat tip. 5/16. Thank you, sir. The shorter length looks like it'll work. We'll save that. So this is how I manage, and this is just a me best practices thing. Lots of companies impose their naming conventions, so don't go back and say, you know, Andrew said, so this must be the best or the right. This is how I like to do my naming conventions for purchase components if I'm allowed, which usually is constrained by company or customer situations. But I usually, and I just cut out that description, let's put it there. So I usually just do an abbreviation for the manufacturer. So in this instance, MCC works, MIC, whatever. And we'll dump it to my desktop. I usually create a subfolder called purchase parts, or PP for short. Otherwise, COTS works, components, was it components off the shelf? Is that what COTS stands for? Something like that. Now, the McMaster-Carr parts are always interesting because their default SolidWorks configuration bill of material label is the configuration. So for ease here, if I look at counterpart, it's going to tell me that it's the wrong number. I really want to say MC dash. So I'm going to right click on this, go to properties and say document name. And I'm just using counterpart here because it's easier than looking at the bill of material. And now it's going to be MC dash. So changing that is going to direct counterpart or direct SolidWorks to say the bill of material value for this rubber bumper stud, whatever Radar said it was, is the actual document name. Let's see if our clamp has downloaded. Download CAD model. Oh, now that I've got this, let me copy that description back in. So I'm just using, I have an F3 hotkey for file properties. So let's just go here and say description, paste that in. Works for a user group demo. Didn't mean to close that. Let's try opening that again. All right. Now, looking at this, let's open up that folder. It's a parasol. Let's cut this and just paste it in my purchase parts folder. Yes. Was there a question? Eyebrow itching? Is that a symbol of some kind? No. Okay. We'll open this up in SolidWorks. I'm sorry if anyone is here for the first. It came with a clamp. You misled me. All right, well, that opens surprisingly easily. So we'll. So before I save that, I'm going to just right-click and make all of these components virtual. If I can read, make virtual. Again, or have to save it first. Duh. So Destaco is a good enough abbreviation. Otherwise, I usually do. I think it's DST. I don't know. It's been a long time since I've done a Destaco. Whatever is you make it up as long as you stick to it, it'll serve you well. The problem is when you make up a standard, you don't stick to it. So now let's make them virtual. And what virtual will allow me to do is it'll embed all of the subcomponents inside of the assembly file. You can only make parts and assemblies virtual inside of other assemblies. So now when I hit save, I can go to my purchase parts directory. I can download my original Parasolid file, and I can download or delete all of the parts that I got downloaded. So I now have a single part file, which is my McMaster bumper, which I may or may not need, and then a single part file, which is a SOLIDWORKS assembly that has subcomponents embedded inside of it. So going back to the design now, let's insert in this Destaco clamp, which I should quickly, while I'm thinking about it, make sure that those child parts are hidden so that SOLIDWORKS recognizes this as a part file, not as an assembly file. Close out some of these folders. For some reason didn't work last presentation. All right, so let's kind of move this around. Right click with the mouse and move will rotate a single object that's not fixed. Scroll click with the mouse will move your entire graphics pane. So let's say we want it to be right angle mated to that. Drag it away. Let's just pick an arbitrary dimension of, or could probably be right on there. So let's say we want to meet that face coincident. Okay, so that face must not be perpendicular to that side. It is not, it's 90.0 something. So we'll just pick the edge then and the bottom there in coincident and kind of sort of center that maybe. Pick this and do that as coincident. So then we'll have to just pick some arbitrary size there. Looks like I will need that bumper, and it looks like that is too close. So I'm a big fan of breadcrumbs, so I need to adjust this mate so I can move it over so I can have another one of these. Maybe I can put one in the middle, we'll find out. So I click on my Destaco clamp and hit D for breadcrumbs. I can hover over this subassembly, and breadcrumbs is just your hierarchy chain. I can hover over my mates, find the mate that I need to edit it from here, change it to distance, maybe 1/4 of an inch. It errors on me because that's what SOLIDWORKS does sometimes. So something's not right, so let's look at my properties. That's perpendicular, shouldn't have mattered. That's coincident, shouldn't have mattered. That shouldn't have mattered. So why did it error? Who knows? One of those, don't know, just move on. So that's 1/4 of an inch. Again, breadcrumbs, grab that, pick that. Say 375. Looks good. And then maybe we'll make a mounting block for that in a little bit. So it looks like they're at different levels. So maybe I'll move it back more, and the one that comes with the Destaco clamp will bolt the bottom one, and I'll throw the other one that I downloaded next to it. So let's just do 3/4 is good. Now let's insert that McMaster item. Looks like it's a smaller thread there. But it looks like this thread is kind of too bad. Radius, yeah, whatever. We'll throw it in there. So now I just gotta find the center plane. So let's pick on this, pick on that part. It'll allow me to pick a plane from breadcrumbs, which is super awesome. Let's hit mate. Let's expand this McMaster item, find the same plane. So now that I know it's in the center, right? Everything's moving around. Let's just define this a minute. Let's grab that point. Usually don't use points, but I want to let me do a distance from there. That should have given me a distance option. There it does. Didn't in the preview for some reason. Okay, So it's a little off, but it'll keep stuff from moving around. So I've got another bumper here. So maybe I'll have to figure out later what the size is, get those little washer clamp things to make that work. But that's the concept, or maybe I replace them both. Maybe I put in a subplate. Who knows? We'll get there at some point. This is where if Jerry was around, he'd tell me what to do, but he's not, so I'm making it up. So now for this adapter, or this corner block real quick, I'll just draw it offline. And I don't know the sizes. This is one of the things that I do quite frequently. I don't know if everybody does or not, but I just guess at stuff or put random things in. And we'll say it's 2 inches. Throw this into my regular sort by name, riser, form, because I don't anticipate this to be configured, I'd take off the X. So it's just 4. Again, dump it back into my assembly. Oops, close that out, don't need it. So I'm just using Control-Tab to get between my windows in case somebody didn't know. It's like the same thing as going to Windows and switching that. So insert this component here. I always try to draw everything in machine position, so as I drew it, it should drop in there accordingly. Select Other, Coincident. I probably want the block the same size, so I would just click on the bottom edge here. You could also use the measure tool. Anytime you click on an edge, it'll tell you the length, so 2.5. Just got to change this to 2.5. And it looks like it needs to be a little bit farther. This I would use the measure tool for, grab that face and measure it out about 0.65, so we'll just do another 3/4. 2 3/4, good nominal size. Mate those edges together. You could also mate planes together if you wanted the block in the middle and not the same width, but edges will work, or faces will work just fine. And then we'll probably want to move that up like so. And this is where it's going to get fun. I'm going to do a distance mate from the... I'm going to change that actually. So I'm editing the sketch. I want the origin to be on the center here. Whoops, midpoint there. So that I can use a distance mate from the plane on top, because that's what's important to me. Let's say it's 11 inches, close enough. Because I can't reliably mate to the top face because I hack it off on the side on an angle, I don't want a distance mate from the bottom because then it's going to float differently. So I'm distance mating, again, click on this breadcrumbs. I'm distance mating from the plane, which is stable because that surface is going to get cut, to the base plate, which I know is never going to change. If you go from the bottom and you want that block taller or shorter, it's going to change everything else. So now that that's done, I'm going to edit to this block in context, insert a sketch, convert those edge entities, power trim off the excess, convert that edge, power trim off the excess, do a cut extrude through all, did not mean to do through all both, green check. How is it not closed contour? I converted that edge for some reason and I think I accidentally, did I? Okay. And there now it's a fully defined block because I didn't use that top face to constrain anything. Now this part here, I'm gonna adjust my distance over. And instead of that vertex, which is very unreliable, I'm gonna pick the edge, which is now parallel to what I'm trying to do. And I'm guessing I'm gonna do like 625 and invert that dimension. Oh, so close. Yes, that will work. I'm not going to say that's a bad idea, and I'll just do it here because it's a worthy suggestion to demonstrate. I generally don't like the midpoints, and especially for this where it doesn't matter enough to care. But Radar has a good suggestion, so we'll do the front plane there, do mate, hover, does it show up? There it is. Pick the midpoint. You can also right-click on any edge or line entity and select midpoint there. But that also works, that does get you in the middle. The reason I don't like the midpoints is because then if I have to chamfer a radius or I do anything that destroys that edge, and edges are always defined by where two faces join, so if you affect one face or affect the other face, or affect the edge, or maybe, like, let's say, for example, if this part is edited, and I fill it just this one side, right? Now my midpoint got adjusted. So I consider midpoints to be highly volatile in a design intent standpoint, and from a practical purpose standpoint, I always try to stay away from volatile when possible, right? That's why I said the vertex there just is, because vertex is the worst of both worlds, right? It's where 3 or more edges connect. Each edge is defined by a face. So you have one of 6 faces that could possibly change that could destroy your vertex. So radar's suggestion is good. I'm not going to say it's not a valid thing. It's just not my style. And in this particular instance, because it doesn't matter. If it did matter, let's pretend that this would be my method. I would draw a line from the middle, and then I would mate to that line. Because a lot of things can blow up that will hurt the line, but then my mate always works, and I can just fix the sketch, and the sketch would be yellow, and that's easier, in my opinion, in mind, it's easier to fix a broken sketch than it is a broken mate that lost geometry, you don't know where it went. Because if I was to chamfer or radius this edge, the mate would just be gone. It says I used to be part of a midpoint, I don't know where. And at that point, I don't know if the midpoint is on top or on the bottom or somewhere else. So, yeah, maybe you have more confidence in solid quirks than I do, but so I'm going to pick that. Again, breadcrumbs are awesome, guys. If you're not using them, use breadcrumbs. It saves you so much. The standard SolidWorks key for that is D, as in Delta, but the breadcrumbs are fantastic. So then I hide the line because all good designers hide extra lines, axes, and planes if they're not being used actively or unnecessary to see. And I'll get rid of the rest of this at some point. That's my opinion, at least. So now I always want my block to be at least as tall or taller as it is wide from a leverage factor standpoint. So this doesn't look good enough to me, so I'm going to change this to maybe 4.5. And this is where mating to that top plane was helpful, because no matter what I change that dimension to, that block's always going to stay relative. So now I'm going to edit this and say I want a socket head cap screw, 1/4 inch is fine through all. Let's go down enough that we're going to avoid the clamp. Oh, we'll just put a couple in the middle, that'll work, and then maybe a couple down here. That sounds good to me. Pretend this customer doesn't care enough that the Destaco clamp is doweled, is possible. A lot of times I put holes in the design just so that I get the right machine position and I kind of know where I want them. And then I'll open up the part and define the rest of the holes later in just the part context, so it's a little bit easier to control. So in this instance, I say I want them 3/8 away from the edge, and these first holes are 1 inch. I'm just typing a nominal, right? It doesn't matter at this point. 3/4, good enough. So I want a couple up top because that's where the leverage factor is going to try to be away, and then the couple down below just for stability. Then here I could edit this part. What arc is this? So 1/4 inch will work. Insert a hole wizard here, tapped holes, 1/4 Don't want to go through all on a tapped hole. Somebody from the machine shop, if they're doing their job well, will give you a friendly and polite call, in my opinion. And maybe those holes are a little small. We can maybe move to 5/16. Try to stick to a single fastener size per general design. And another way to check the size of your holes is pick this option, which is how much the threads will remove to make sure your bolt fits. You don't want that for final design, but it's a way to check. I try to stick with a general fastener because it's just one size bolt, one size wrench, one size whatever, unless you're bolting to purchased hardware in which the size of the bolt is defined and dictated to you by what it is that you're purchasing. So pretend that's good enough for the end customer at hand. I could now edit this component in position and do a 1/4 blind tapped hole. Any idea why SolidWorks defaults the tapped hole to a 1/2 inch depth, or the tapped part of the hole to a 1/2 inch depth? I think the diameter drill is 6.5 or something. Why is it a 1/2 inch for a 1/4? 1/2 inch for a 1/4. Did you say 3 times?
2 times.
2 times. Did you say 3 or 2?
I said 2.
I'm sorry, I can't hear. I thought you said 3. Yeah, so general machinist handbook rule of thumb is double the diameter will give you maximum thread holding. Any more than that is unnecessary. Any less than that, then your threads will rip before your bolts. Aluminum being softer, sometimes 3 times is the preferred method, or for plastics. But generally any mild carbon, steel, stainless, whatever, 2 times is kind of your golden rule there. I don't know what material this is. I would assume this is making part contact. It would have to be steel. Jerry's not here. I'm not sure. A2? I don't know. Jerry would have answered me that if he was here. I'm guessing because these are just light aluminum tubes, I assume. It might just be like an aluminum with a hard coat. You could do like type 3 hard coat. I don't know. But the point is SolidWorks defaults at double the diameter, which is like a 99% always case. If you're going to rip out 4 quarter 20 threads on a Destaco clamp, it's probably a problem. And I just noticed a problem that my hole here is too high. It's going to run into my tube profile, which I do not like. So I'm going to double click here, double click there, make that 1.25 inches, rebuild. I might close up these holes a little bit just because I had to move them down. Oops. Recheck. Right on the ragged edge. Let's try that again. 375 inches. Good enough, right? So always check holes, interferences, accessibility to holes. It's really frustrating to work on a piece of equipment where you gotta like put it in a jigsaw puzzle way because you gotta get at the bolts and stuff. Yeah, that's burned me a few times. All right, so that's done, that's clamped, that's good. I don't remember what was happening here for positioning it or clamping it or checking it. We'll pretend that we have to clamp that as well, so we've got our handy clamp already. Now the problem is going to be fixturing this to the plate because it's at a double compound angle. I'm not going to be able to just cut a one-side angle on this, which is easy for machining. I don't want to do two-side angle because that's difficult. You either have to do some very fancy sign block setup or you have to 3D contour it, which is even more difficult because you have to set up on that 3D contour to put in your tapped holes, which nobody wants to do. So typically my approach here is to rotate this until I only have a single compound or single angle instead of 2, and then just put it angled on the plate. But it might look a little weird. So let's pick, I think I can pick that and the side surface and say perpendicular, and that is going to give me a single angle. So if I look at this somehow, or do I got to go perpendicular or something else? I'm losing it, man. I think it's perpendicular this way. It appeared to be the same answer. This to that. But then if I look at this, oh, thank you, Todd. So now I can just do a single angle because I can twist that bottom block to whatever I want. Now when I'm making this particular block, this is going to be hackish and dirty, so I won't leave it like this, but here's the example. To take this block and put it in a vise, I can side mill that. I can side mill that pretty well, or put it on a right angle block and sign block it or whatever, right? And I can deck this pretty easily. A double compounded angle, and that would be very hard. Now, to get this angle, and it's not fully defined, so what I did there was a really hack job, but because as I move this around, it's going to be tall or short. In this instance, it's slightly short, so rebuild will make that change. But basically, you would kind of move this around until you liked it, fixed it to the base plate, however it is, and then put in your holes at whatever weird angle they are, and you have your block. A little bit of thinking through it and a little bit of a weird design. Some people will look at that and be like, oh, that has to be square, it's going to look weird, it's going to be off. But you're going to save like $500 or something. And sorry, what was your comment? What's another way of doing it?
Block your post standing up square to the plate, and then take and put the angle on there, and you just rotate the angles.
Oh, like measure the angle of this to the plate, and then put that angle on there?
Take your, put on there, take it and twist your, put your angle, and you rotate your angle to the top block.
change the angle of this block. I'm not following what you're saying, sorry.
You got an angle, you put this angle on there, and then you just tip your angle.
Oh, yep, I see what you're saying. You could take this block and move it offside, and then you could rotate it and then take another angle block. I don't disagree that is a valid option and sometimes necessary. In this particular instance, everything is hard doweled, and the stack ups, I would minimize that as much as possible. I'm not even really thrilled with having a block on top of a block, but because this block requires machining at that particular angle and stuff, I think it's probably worth it. But you could also just elongate this block, and then you'd have to have a setup here and then turn it and have a setup there. But that would also work from a geometric side. Your comment, Radar?
Probably save 15 hours of CNC, not having search.
Right, 15 hours of CNC time at a reasonable $100 an hour or something. Yeah, whatever, right? And then plus another part, another setup. If everything is hard doweled, you still need to set that up then at that double compound. I think I commented this earlier in the last class, but during the design, everything here is my opinion, right? If you don't like it, then you can get your money back as you leave. But general design, if you're not thinking about how it's gonna be made, you're doing it wrong. Like if that is not in your mind, and if you don't have the experience or the tenure to do that, hopefully you're paired with somebody that does. Or I highly encourage people, Radar, you had a young guy working for you named Withheld who made a design, printed it out, walked down to the shop and asked them what they thought of it, if I remember the story correctly. And the person who told me the story commented that never in his 20 years of experience did he see somebody do that. If I remember the story right. Yeah, I don't know. But anyway, I like to hear that story, right? Because it recognized that the person had opportunity, they knew that they could learn something. And a designer actually took a piece of paper and went to a machinist and asked what they thought. That in industry, I mean, from what I observe in industry, that's very rare. I don't know if you guys experienced something different, but I thought it was very good I enjoyed that story a lot.
I've done it before, and I've encouraged
Good. There you have it. Radar is a great guy to work for. All right. So we'll pretend we put holes in that block. I don't know that we all need to watch me do that. I don't know if I even have holes in this one. We'll do it. It might be fun. So I'm going to find the high surface, because if I remember right, these are changing a little bit. So it looks like the middle one is high. So I'm going to pick on the high surface and do a hole wizard. Countersink hole, 1/4 inch. Through all, countersinks are generally through all. Let's, I make a lot of faces when I design, I guess. Never realize that until you do it in front of people and they laugh at you. So let's go ahead and do that. What I was trying to debate was, I picked a binding head screw, which is wrong. Let's change that to socket head cap screw. What I probably should have done in this particular instance was pick the low face and then started a sketch there, converted those entities, and cut the geometry back out the other way, because that would always give me the right depth. That's probably what I should have done. So we'll do it that way. So I've got holes. Again, it has to be doweled, so on the back side here, let's put in some blind slip fit dowels. So dowel holes, 1/4 inch clearance. We don't want through all, let's do blind. Now again, what's the rule for dowel holes when it comes to depth of diameter? I'm sorry? 2 times. I don't disagree. That's a good rule, especially on the press fit side. On the clearance slip fit side, that's purely alignment. Generally, 1 times diameter is my experience is more than sufficient. Your mileage may vary.
Depends on how tight the clearance.
Sure.
I've seen dowels push back out. When you press a dowel, air passes so much back out.
There's also that. I'm just gonna say, tongue in cheek here, that if Radar keeps having all the answers, he should do a presentation. He's smiling, he's not saying no. So in this instance, I'm just using the origin, which I designed center mass, to be my mirror about instead of actually doing a mirror because it's a mirror catty corner. And it's easier to draw one line and pick midpoint than drawing two other lines and making them parallel. Or equal, I'm sorry. So there's my dowel holes, catty corner, kitty corner, depends on how you want to call it. I guess it depends on how far south you were when you grew up, is what I was told. Now this part is not yet fixed, so we'll just pretend that it's fixed and bolt it to the plate, and that's kind of how that worked. And so here I'm going to hide the customer part, edit to this part, pick on that top face, do a U for a hole wizard, pick my, in this instance I want to do dowels first, so press. So this is an instance where I would do clearance in both because I don't want to press fit into a blind hole on either side. I don't want the holes to go through. So I would do clearance in both if tolerant stack up was acceptable. In this instance, I might do 3/4 of an inch. So I'm just going to pick and place a couple holes, go to my right click, select other, and place those holes based on where they were in that other part. So now I can green check out, and then again, hole wizard, take my tapped holes, 1/4-20, restore defaults on tapped holes unless necessary otherwise, drop those in there. And now if I open this part, I'll see that my dowel hole is pretty dang close, if not breaking through. So based on how this part is rotated, man, I cannot click today. Based on how the part was rotated, the holes didn't really pan out well. So maybe I'm going to change this to 2.5, move it around a little bit, make sure I get the coverage I need. I could also alternatively change the corners at which the dowel holes are in there to give me a little bit more room. Maybe not necessary. Move it around. Sure. This seems like a very unspecific scientific method. It's because it is. In the world of external references and CNC design, I really don't care. I would put now a couple dowels in the bottom of this and a couple tapped holes, and then wherever this ends up, I would throw a mate or two on it and drive the holes of this block down into the base plate, which maybe I'll get to later today, or maybe the second session, maybe we'll get to some of this and start doing some detail work. We'll find out where that goes. And this is pretty much the level at which I finish the design. I know for a fact that I can put holes in the bottom here and they'll go through the plate. That's not a fit, form, function problem. The more challenges, do I have room for the Desago clamp? Are the holes that are holding this block on hitting that? Can I fit holes in here? So I'm putting holes in the design where necessary to validate the design at its current stage, and I'm not putting holes in stuff realistically where I absolutely know with beyond a reasonable shadow of a doubt they're going to fit and I'm not going to have any problems. So if you're asking for why I'm being so eclectic at my hole placeage, that's that answer. Any questions so far? I've been rambling for a while. It looks like I got another 10 minutes if they give us an exact hour, or 5 minutes if they cut us off when the schedule says.
I can show you another thing. One you did the counterboard hole on that surface.
Up here?
Yep.
Or here. Sorry. Yeah, you can also manually adjust the counterbore depth. Is that where you're going?
Yeah.
Yeah, and that is an option. That's kind of what I half thought of at first. The disadvantage that I have with that, here's what radar is saying. So if I pick the top surface and I want to counterbore here, there's not enough distance from here, try that again. If the counterbore is, let's say, here, we'll put it right in the middle. There's not enough distance from here, so I need, what is it, 1/4 inch? So I need 1/4 inch to bury the bolt head. And if you do it wrong, you're only going to have less than 1/4 inch, which is a problem. And instead of having to edit the counterbore and then do a head clearance and manually key in a number, I don't like that method purely because of the design intent aspect. If something else changed and I didn't remember that and go back and edit that feature and go rekey in a new head clearance number, should something change, then your design's not going to fit. And after you've hard coat, anodized, or oxided, or whatever it is your block, then you have to go recut that counterbore deeper or grind off a bolt head or do something else crazy. So generally, as you saw me go through the decision-making process of the design, in this instance, I think I would probably pick the lowest surface that I have to clear, right? Because the distance from here to here is only 1.5 and we need 2.5. So I'm 100 thousandths short. So generally, I would pick the low surface, bury it, and then you get a result that looks like this, which to me is acceptable from a design iterative process standpoint. And then do a dumb cut extrude that's through all the other way, because a through all cut extrude will always make up the distance. As long as my counterbore starts on the lowest surface, I'm never going to have head clearance issues, and the design will, quote, always work.
Well, but when you go to the detail.
It'll work no problem.
Will use the whole wizard, call it like that.
Go back to
Well, it should all be CNC designed, and my opinion, generally, counterbore shouldn't call it depths. So I don't know. Let's find out what my detail drawing says.
Then you're gonna get the guys out on the floor that are gonna yell at you because your counterboard is not
Okay, we'll make a 2D drawing in the 7 minutes I have left.
depth in the block that it's tapping into. So then they gotta grind the screw shorter, get some threads off.
All right, so quick tip here. I don't design all the time, and this computer is relatively new, so I don't have the right button set up. I don't like clicking the down arrow on the new just to click make drawing, because I make a lot of drawings, right, when you're doing type of design like this. So I'm going to search in the command manager for the make drawing from part/assembly command option, and then I'm going to from here drag it into my command or into my header. So anytime you do a search in the command manager or in the command search, you can, without tools customized, you can drag that command that you found around. So now I can just click this one button, it'll ask me to make a drawing, it'll come up with my drawing template, and let's see if all of the doom and gloom predictions come true. Real quick power rant on how to do drawings. Always make the details, if it's not square, horizontal, because it fits in vices that way. No machinist, realistically, puts their vise on sideways to hold a part like this. So click on the part, click the rotate, do your 90 degrees, hit apply and close. And then also change this to hidden line shown, which it is. So now that it's rotated the right way, I'm gonna click on it, do projected views, project over, project ISO, project bottom, and there I have an actual manufacturable print in that context. So let's save this real quick. It looks like the other, no, they're not getting, no, Greg is still going. Greg's going, I can go. So let's try Hole Wizard. What is Hole Wizard gonna give me? Hole Wizard is gonna give me a proper counterbore hole callout. It does have the depth, so I must not have my settings on here. The depth is going to be called from the Hole Wizard feature, so that 1/4 inch certainly is wrong. I would probably do let's just drop a section in there. I don't need that, we'll delete that view. And then I would go out of my way to call this and say this as a max value. From there, we'll do some ordinate dimensions. Where's my sketch toolbar? And again, I want ordinate dimensions, so I'm gonna drag this right below my dimension tool because I use ordinates a lot. I always ordinate off the upper back left corner because, who wants to tell me why? Because that's how machinists set it up, right? The back of your vise never moves. Well, normal typically, right? The back jaw of your vise never moves, the front jaw moves to the back. And if anybody ever sets up a vise stop, the vise stop is always on the left because normal people are right-handed, left hands are freaks. So you typically put the part in the vise, move it to the left to your 0. And if you consistently set up your prints this way, then your machinists don't have to pick a new freaking 0 every time they want to make a new part. If you've ever been a machinist, talk to a machinist, have sympathy for machinists, you will understand that concept. So let's grab my chamfer dimension. And in this instance, right, that section really needs to go the other way. So let's section it this way, down there. And the section needs to be that way so that I can call out those different depths or those different heights. So ordinate from here, I would go from bottom because that's going to be my common plane. Pick that, pick that, pick that, pick that. And I think that's all the time I have. Everybody else is getting out and there's talking. So we got to 2D prints a little bit. Next session will be, I promise you, an equal amount of fun or more or less. It kind of depends. Thanks for your time.